for example, when we're talking about rays, if I say we have ray AB, if I say that and I want you to draw that, what does it look like? How would you draw that? Yeah, it doesn't matter which way, as long as you, which one's your endpoint? Right. A has to be the endpoint because A is the first letter. A is the endpoint because A is the first letter. Now, you just put a dot, label it A. It doesn't matter where you draw the arrow from then. Does not matter what direction you go, as long as you just label the other spot B and put an arrow through it. That's all you have to be able to do. Okay. That's all that is. It could be. But remember, a lot of the vocab is like, if you see that you have a ray or a line segment, you have to know how to draw it. And that was the whole idea with a lot of these things. So, yes, ma'am? As long as you should have to, because it's saying it goes through, it's A, B, so it goes through point B as it continues through. This is the correct way, the official way of drawing it. All right. Now, what if you had to say that you had segment XY intersects segment CD at point D. How would you draw that? Question?
We're having a quiz today, right?
Tomorrow.
It was Friday last week. Continue.
How would you draw that? Yes, ma'am.
Okay, I'm just gonna make this so
Why don't you just go draw it? Because it's easy.
Yeah, it's
So wait, 1.4, 1.5, and 1.2?
We usually spend 2 days in 1.5. It's all on the calendar too, guys. If you look on the website, I put everything on there for you guys so you know what's up. Yeah, absolutely. That's just one way of doing it. You can, there's probably infinite amount of ways of doing it. It's just a matter of drawing it, really. What if you said that segment XY intersects segment CD at, let's change it. Let's say it's at a midpoint E. If I want to say it intersected at the midpoint E, what would I have to change here? I have to put an E in. Does it go on XY or does it go on CD? Yeah, I just put a midpoint in, and I just move this over like that. I could do that, and it works as well. Okay. Question was? So it's just a matter of being able to remember what definitions are used. Like Kyle was asking, do you have to know all your definitions? Well, yes, but it's not that it's a vocabulary, matching style quiz that you guys are accustomed to seeing. It's a matter of, can you use the vocabulary to draw a picture? Can you use the vocabulary to set up a problem? Does that make sense?
Yeah.
Now, the other thing we did in 1.1, the 1.1 was pretty straightforward. Drawing pictures, using that, being able to get the lingo to it. As you got into 1.2, we started to put your foot down, please, or I'm going to have you stand. Thank you. As you got into 1.2, we started doing stuff more with algebra. Oh, here we are. We started doing stuff where you had to actually draw out the picture again. Oh, I must have exited that out. I'm sorry, what's that?
I think I accidentally exited it out.
Oh.
Sorry.
This one says point J is between H and K on H, K. Now, we did problems like this where we had algebra that you had to build out of definitions, build out of a diagram. So if you look at something like that, obviously, what are we missing right away?
What's the first thing you should do in a problem like this?
Yeah.
Draw.
Draw it. And does it matter where you put J? Well, all right, I see people saying yeah and then no, and yeah, as long as, yes, it does matter. It should be between H and K. That's basically what you have to worry about.
Does it have to be in the middle? No, it doesn't say it's the midpoint.
So again, as we got through these things, you guys noticed that most of the algebra that we had to do wound up being fairly simple. Just by filling in the blanks. So by filling the blanks here, we had, what, 5x minus 3, x minus 9, and the whole thing is 5x. And now it falls back to that good old-fashioned segment addition, where you have two smaller segments that have to add up to equal a larger. So if you write it out, you're going to get 5x minus 3 plus x minus 9 equals 5x. And this is the idea of writing it out like this in the diagram, so that way it's so much easier to notice that two smaller parts make up the whole. Okay. So when we do that, we get, what, 6x minus 12? That's a really, really fast one to work with. Subtract 5x, add the 12, what do you get? Now remember, it doesn't always just say solve for x, it's going to say solve for HK. It's stuff like that. So you always have to read instructions carefully in a geometry problem, because they have you use algebra to do the geometry, if that makes sense. Okay? So that happens all the time. Okay? We okay with segment addition stuff? Yeah, you guys kind of flew through that. It wasn't too crazy. And then the last little bit we worked on over the course of a few extra days wound up being all the midpoint stuff. And when we did midpoint, it's distance versus too many things. When we worked with midpoint, scroll back up, far. Hey, there we go. We did this a couple of different ways. I hate the scrolling on this thing. It's awful. We talked about midpoint, we talked about a bisector. What's the difference between a bisector and a midpoint?
Gray line or section that intersects the section and its midpoint.
Yeah, that's all it is. So if I wanted to find the midpoint, do two different things here with these. Say we have the ordered pairs. Oops. I want to do two different things here. Let's find the midpoint of ST, and then I want to find the distance of ST. Remember, that little D in front of a segment always stands for distance. So take a second. I want you to do both things. I want you to find the midpoint of it, find the distance of it, and then I'm going to throw one extra thing at it when we're done. Let's see if we can figure that out. midpoint. Now remember, when you find a midpoint, the easiest thing to do is we're just finding the average of the x values. We're finding the average of the y values. So what's negative 1 plus 3?
2.
2. Negative 1 and 3.
Two.
What is that economy?
I'm finding the midpoint. When you find the midpoint, you're finding the average of them. You're going to add them together
Divide by 2.
and then divide by 2. So negative 1 and 3 is 2. Half of 2 is 1. So the midpoint is going to be at 1, comma. Well, what's negative 2 and 2? 0. What's half of 0? 0.
Should be negative 0.5. Half of 0 is negative 0.5.
It's 0. Half of nothing is still nothing. Okay. So that's how you get midpoint. Distance, though, on the other hand, is when we're trying to figure out how far apart things are. So when we did distance formula, we did kind of a little bit different here. We would add them together. So how far apart is negative 1 and 3?
No, 4.
They're 4 apart. So we have 4 squared. How far apart is 2 and negative 2? They're 4 again. And then we add them together and take the square
It would be
root.
6. Like it'd be like 16 if you're squaring them.
And a simplified radical form is 4 root 2. Okay. All right. So obviously here's a good point of where the vocabulary comes in really, really important. Where we have to be able to know that when we're finding a midpoint, you find them halfway. Think you're midway there, you're almost there, you're halfway there. The distance is how far have you gone? Now, what if I asked you to find a missing endpoint? If T was the midpoint, what is coordinate for R at the end of it? If SR is the segment, T is the midpoint, T is the halfway spot, how do we find out where R is? Remember that trick? What was it, Whiskey?
Didn't you take wouldn't you do S squared?
No.
Or S.
No. Okay.
Would you do like, since the first element for ST was like plus 4, would you do that plus 4?
Yep, that's exactly right. So when you're finding when you have the missing endpoint stuff, when you know that you've gone so far, going from negative 1 to 3, you went 4. That's halfway there. What's 4 more than 3? 7. So that would be at 7. And then going from 2 to negative 2, do you go up or down?
22.
We went down, how many? What's 4 less than negative 2? Negative 6. So, yes, definitions are vocabulary stuff are very important here in the fact that you have to remember what to do when. Find a midpoint, find the halfway of it. Find the distance, how long is it? Find the missing endpoint, counting up and down. Now for each one of these things, did we necessarily need the calculator? Aside for squaring and square roots, but a lot of it is just counting. Okay, a lot of it is just counting. The other one that we had algebraically with midpoint was when we had this. Excuse me. Good morning. How are you? I'm fine, thanks. The other one is when we had some of the algebra. Let's find that one. When you had something like this. In looking at the diagram here, what does it show you that's happening?
What does that M stand for? What do those tick marks stand for?
Midpoint.
Good. So if those guys wind up being the same, and that's going to be the midpoint, how do you set that up algebraically then to solve for x? Are we adding them? Great, yeah. tick marks here means that these guys are equal. These things, these tick marks mean that these two segments, those two segments are equal. So we set, I'll get this right eventually. Nowhere does it say that we're adding these two things together to add to equal something, because it doesn't say that anywhere. But if we just set them equal to one another, we're going to be able to figure it out. So when you have variables on both sides of the equation, what do? You pick on the little guy. Very good. So which one are you going to pick on? Good. Subtract the 2x. Good. At the same time, I'm going to add the 22, just get it out of the way. And we get 3x is 57. Very good.
And
Now we divide out. Now, you guys ever see how you guys ever been shown how to do shortcut division? Watch. 3 goes into 5 how many times?
19.
1.
Just hold on a second. 3 goes into 5 how many times? Once. How many are left over?
2.
3 goes into 27 how many times?
9.
Done.
What?
It's magical. No, it's not.
That is, right there, guys, that's just called shortcut division. I mean, and honestly, remember, a fraction is just division. It's just a division symbol. It's just another way of doing it. Honestly, if you guys ever learned how to do division this way, remember going that way, long division? This was long, I just did long division, but I wrote it out shorthand. Because 3 goes into 5 how many times? Once. 3 times 1 is 3. Subtract it out, you get a 2. Drop it to 7. 3 goes into 27 9 times. 27. Done. All I did here was this method shorthand. I just did a little shortcut of it. That's all. You do that a lot as we get going. We do synthetic division in Algebra 2. Bless you. Bless you. Where you do a lot of quick shorthand, adding, subtracting, things like that. We do a lot of that in Algebra 2, so you'll see a lot of shortcuts later on. But the question was, what was xz? So if x was 19, you have to substitute into here and to there, and then add them together. Now, one thing to warn you, if you get different numbers or different answers for both xm and mz, you're probably doing something wrong. Because those two should be what? Equal. It should be equal. It should be the same. All right? Excuse me. So what do you get when you put all that through? Whoa, I'm hearing a lot of different numbers here. So this is 38. 38 and 35 is 73. That is what, 20, 40, that's 95. 95 minus 22 is 73.
Oh.
So you got to equal 146. There. Okay. Not too shabby. Too shabby. Good. Excuse me. Oh, I'm sorry, guys. I'm actually starting to come down to something now.
Don't die. It's bad for your health.
Thanks for the concern. What I want you guys to work on this evening is just some review stuff. And I'm not sure if I actually posted it yet or not. I think I did. I know that on the calendar. I don't think I posted it through or not. Yes, sir.
No.
Yeah, that's right.
One of my relatives has cancer. It's spread all throughout the body. It's not good.
I'm trying to remember if I did that or not. Nope, I did not add it in there. Okay. So let's do these problems then, because I had them open. It's in the book. It is page, I'm getting there. Oh, don't die on me. There we go. It works out to be, hold on, Whiskey, come on. It works out to be on page 64. I'd like you guys to do numbers 1 through 13 on page 64. Okay.
13 problems.
1 through 13 on page 64. Yeah, it's a lot of review stuff. It's straightforward. There's nothing new here. It's got a couple of questions, a couple of examples, just about everything that we've done.
Are we gonna do this then, right?
I would like this one. So if you guys, it's on the book. It's there. I mean, even if you want to get rambunctious and you want to go ahead and just. I hate to scroll on that thing.
We have 10 minutes left.
If you'd like to take a picture of this real quick to get the 13 problems, go for it. But I'm just going to leave that there for you.